Hi there. Welcome to the week 4 learning guide for college algebra. And this is part 1. Now, if you need this document here, I'm going to link it below in the description. That way you can print out a copy and follow right alongside of me. I'll also link the other videos for week 4. And don't forget, if you missed weeks 1, 2, and 3, those are available also. So make sure you take a search through the videos and take a look at them. This video is going to focus on functions as well as domain and range. And we just want to make sure we understand those terms. The domain, those are all of the x values in a given function, relation, and the range is the y values. Now, I like to remember that as x and y come in alphabetical order, so does domain and range. So it's an easy way to remember that domain is for x and range is for y. So let me shed a little light on that one. There we go. All right. So let's look at this first example. The domain here, we're going to list all of the x's. Now remember, they come in alphabetical order. So these first coordinates, those are our x's. So my domain here, I'm just going to list out the x values. It's 2 and -7. And then we get another 2, but I don't need to write it again because I already have a 2 and a -6. And then my range, of course, would be all of the y coordinates. So those are going to be your second values in the pair. And again, you can write them in numerical order. You can write them just in a list. Whichever way works is fine. Just want to list them out there. And then the last question is asking us whether the relation is a function. So here's what you're looking for to determine if it's a function. Did any of the x values, the first coordinates, did they repeat? Well, remember, we had that 2 that repeated, remember? And it was only in the x's. I'm only concerned about the first values. That 2 repeated. When that happens, when it repeats, this is not a function. Because in order to be a function, the x values cannot repeat. So I hope that helps with that. Now, in number 2, we're going to look at, well, you know what? Let's go to number 3 because it also deals with domain and range, but it's coming from a graph. Okay, so let me show you how to do domain range from a graph. I want you to particularly pay attention that the ends of this graph have arrows on the end. That means it keeps going. Okay, when it keeps going, we notice that these x's, instead of listing them, I'm going to describe these x's. So this graph doesn't have any holes, it doesn't have any stops, it keeps going in both directions. And that tells me that the domain is all real numbers. All real numbers. All right, now the range are the y values. So again, instead of listing them out, I'm going to describe them. So I notice that my lowest point is here. It will probably be best if you find either your lowest or your highest point, is that's going to be where you talk to us about the range. So you'll notice that this is my lowest point. The y value is 1. That means all my y values are above this 1. So I'm going to say that my range is y is greater than or equal to 1. So instead of listing them like I did here, I describe them more in this manner in number 3. So I'm glad we jumped ahead and did number 3 instead of doing number 2 next, but I'm going to do number 2 now. Number 2 and number 4 deal with functional value. Okay, so this is function notation. We're telling you this is a function called g, and I don't know why I have f's there, but I will fix it on your copy before I put that for you. So we're going to do g of -2 instead of f of -2, and we'll do g of -x. We're editing on the fly here. So this g of x is just telling you the name of this function is g. Okay. And so when I say g of -2, I want you to notice that the x was replaced with a -2. That means you're going to replace x with -2 as well. So you're going to have 2 times -2 squared. Notice all I did was in place of this x, I put a -2. Minus 3 times -2 plus 4. And then you're going to use your order of operations, which we did back in week 1, to simplify. So you've got -2 squared, which is 4. 4 times 2 is 8. So I've got 8 minus 3 times -2 is -6 plus 4. So 8 minus -6, I hope you're using a calculator at this point. 8 minus -6 gives me 14. 14 plus 4 gives me 18. So that works pretty nice for us. Again, all we're doing is replacing x with -2. I'm going to create a little room here to do g of -x. Well, just like we took -2 and replaced x with that, this time we're going to take -x and replace it. We're going to put it in place of x. So that's going to look like 2 times -x squared minus 3 times -x plus 4. Now, -x squared, think of -x times -x is going to give you positive x squared minus 3 times -x would give you -3x. And then, of course, minus a negative would give you a plus a positive. So g of -x becomes 2x squared plus 3x plus 4. Okay, now my last piece, I want to bring in a new piece of paper or a separate piece of paper because I want to do a little bit of side work on this one. And let me just fold this here. There we go. We'll do the work under here. Okay, because I want a little bit more room for this g of x plus a. Okay, so when we see g of x plus a, that means to put x plus a in place of x. So what I'm going to do for this one so you can see it clearly, I'm going to create space where the x was. Okay, all I did was put parentheses where the x's were, and now I'm going to fill those parentheses with x plus a. And now we're going to simplify. Remember, this x plus a squared really means x plus a times x plus a. And what we're going to do is we're going to use the distributive property to multiply that. So I'm going to distribute the 2 here, and that will give me 2x plus 2a. And then I'm going to distribute this minus 3, but I'm going to distribute it as a -3. So I'm multiplying this to give me minus 3x minus 3a plus 4. Now for this one, I'm going to have to use the distributive again. So I'm going to distribute the 2x to both the x and the a. And that will give me 2x squared plus 2ax. Then I'm going to distribute the 2a to the x and the a, which will give me 2ax plus 2a squared. And then, of course, I still have all these other terms, minus 3x minus 3a plus 4. And now all we have to do is collect like terms. Okay, so I see my 2x squared term. Then I have these two that go together. That gives me 4ax. Then I've got plus 2a squared minus 3x minus 3a plus 4. And I can't go any further with that because there are no more like terms. So that is what my g of x plus a equals. Now I'm going to use a similar approach to number 4 here because we have that same notation, right? This means put -4 in place of x. So I'm going to take my h, but notice I have to put it in place of both x's. So I've got 2 times -4 plus 3. And on the bottom, I've got 3 times -4 minus 2. So 2 times -4 would give me -8, plus 3 would give me -5. And then on the bottom, 3 times -4 gives me -12, minus 2 gives me -14. Now, both of them being negative makes this be a positive 5/14. Okay, now this b here, negative h of x, that is different than when we substituted in negative x for x. This means to put a negative in front, okay? But because this is a fraction, you're either going to put it in front of the top or the bottom, but not both. So I'm going to go ahead and just put it in front of the top. You'll notice that I used parentheses, and I did that so that we would distribute. Okay, so I'm going to distribute this negative to both terms in the top. That'll give me negative 2x minus 3 over 3x minus 2. So remember, when you have the negative in front of the function name, it's a negative on the top or the bottom, but not both. Okay, now C, we're going to put in x minus 2 in place of x. So let's see, that would be 2 times x minus 2 plus 3 over 3 times x minus 2 minus 2. So distribute your 2. That'll give you 2x minus 4 plus 3. And on the bottom, go ahead and distribute your 3. That gives you 3x minus 6 minus 2. So on top, you've got 2x minus 1. And on the bottom, you've got 3x minus 8. So I hope that helps with part 1 of the week 4 learning guide. As always, if you have any questions or would like me to do another video on a similar topic, let me know in the comments below. As always, the biggest thanks you can give me is to hit that subscribe and like button. And I hope you have a great day. Bye for now.